Hi everyone, Miss Andronicus here, and today we are looking at solving linear inequalities. So linear inequalities, when you go to solve them, it's very similar to just solving linear equations. What you do to one side, you do to the other in order to cancel and of course ultimately solve. So for inequalities, one thing you can do is add the same thing to both sides. So to solve this, once again, we want to get x on its own. So we've got a -5 to cancel it out. We need to add 5 to both sides. To get rid of it on that side, x is on its own, and then you have 8 plus 5 is 13. Okay, so x has to be anything less than 13. That's just solving an inequality. You can also subtract the same thing to both sides. So here we've got the 8 on this side. We want to subtract it off in order to cancel it off. So you end up with 2. So x is greater than or equal to 2 in this case. For these examples, you can multiply or divide both sides by the same positive number. So here, again, to get x on its own, you have to divide by 3 on both sides. So then you end up with x is smaller than or equal to 4. And on this example, you've got to multiply by 2 on both sides in order to cancel that out to get b to be greater than or equal to 16, okay? Both are accurate. But the exception and how these are different from linear equations is if you multiply or divide by a negative number, you must reverse the sign, okay? So let's have a look at this. So for this first one, I'm just going to proceed like I'm solving any linear equation. So I'm going to subtract 5 first, subtract 5 on both sides. That stays the same. That ends up being 14 and negative 2x. Now I'm dividing by a negative number. Divide by negative 2 to cancel that out. Divide by negative 2. Here is where the x comes down. That becomes negative 7. All the same. The only thing is when you bring down this sign, it flips to face the other way. That's it. That's the trick. Okay, so have a look at this example. To cancel that negative 3, I need to multiply by negative 3. Again, I'm multiplying and it's a negative. So the b is on its own. You do the calculation, that's negative 18, and you flip the sign the other way. To prove the last rule, I'm going to show you this. If we know what both of them are on each side, this inequality is already solved, it makes sense. Negative 3 is less than 5, no problem. If I multiply it both by a positive number, then I end up with 10 and negative 6. This inequality still makes sense. Negative 6 is less than 10. If I go and do the same inequality by multiplying it by a negative number this time, the 5 becomes negative 10, and the 3, negative by negative is a positive, becomes 6. So I can't keep the sign the same way because that would be like saying 6 is less than negative 10, which we know mathematically is incorrect. So therefore, to make it make sense, we need to flip it around. This is why this last rule is the case. Okay, have a practice. Don't forget, if it's an inequality, keep in mind, is it negative and are you multiplying and dividing? Okay, thanks guys.